we want to figure out what is a test. A test ultimately is a way of verifying some other code to make sure it works. We can manually test something by running the application and making sure that we get the results that we're looking for. The other thing that we can do is we can automate that. So instead of manually running the application, we could create code, other code, that tests the code that we're trying to verify and make sure it works. So that's the idea of this. In order to help make that concrete, because it's a little abstract, we're going to run through a couple of examples to see if we can figure out what is a test, what does it look like. I've got a C# application here. We'll go into this mirror class. So the mirror class here has a single method called reverse. Reverse takes a string text, so a string argument coming in, and it's going to return a string when it's done. And effectively, we would expect this to just reverse the text. We can look in the method itself and we can see exactly that. So we're taking the text, we're reversing it, calling toArray, and then passing that to a new string, which reverses the text. So if we were going to verify this, if we were going to test this, we might give this method maybe a couple of different values to make sure it works correctly. So let's do that. We're going to do that through an automated test. We'll go into our mirror tests class here, and I'm going to rename this test method to something a little more meaningful. I'll call it mirror_reverse because we're testing the reverse method. Underscore, and we'll say text is testing. So we're going to use the word testing for our test here. So to make sure that if we pass the word testing in, we get testing in reverse coming back out. So let's do that. We'll say text is the word testing, and our expected value is going to be, I'm going to type this backwards, which is a little harder, GNITSE capital T. That's the expected to come back out of it. Now we need to actually exercise the application, exercise the code. So we'll create a mirror object. And then on that, we'll say our actual is mirror.reverse. And to that, we'll pass in text. Then finally, we want to make sure those are the same. And we do that through assertions. That's where we basically say, this should be true, whatever that happens to be. I'm going to use the assert class and call equal and say that our expected value should equal our actual value. So our expected value is the word testing in reverse. Our actual is what comes back out from the method. Let's run this really fast. And we will see that we get a pass. It passes, it works as we expected it to. No big surprise there, since looking at the function, it does what we want it to do. Let's do another test real fast. I'm going to copy and paste this. And instead, I'm going to say text is Chad. I'm going to use my name. So we'll say Chad here. Now, if I run this as is, we're going to notice that we get a failure. And the reason we get a failure is because the actual value was Chad in reverse, which is what we'd expect, but our expected value is still testing in reverse. So going back to the test, I need to also change the expected value to be my name in reverse, which is hard to type in reverse. Now if I run the test, I get a pass. So that's how we're verifying and making sure that the code works. Let's do another one more test on this to show what happens if we do get a failure where the code actually doesn't do what we expect it to do. I'm going to copy and paste again, and this time I'm going to say text is null. So what happens if I pass a null value in for text? I would expect to get back null. So if I pass null in, which is no value, I would expect the reverse of that to simply be null, to just give us back a null value. Now if I run these tests, run everything, I'm going to get a failure on my text as null. The reason for that is we have an argument null problem, or a null reference exception. So going to reverse, we go to text, which is null, and then we call the reverse method on it, which we cannot do. We cannot call a method on a null object. So now I actually have to change my code to make the test pass. The test itself is valid. This is exactly what we're looking for, but the code itself isn't handling the null correctly. So I'm going to do a simple guard clause. There's a few different ways to do this. I'm just going to do a guard clause to say if text is null, then we'll simply return null. So a real quick check to just say if null's coming in, return null. If it's not null, go ahead and do what we were going to do in the first place. We'll run these tests, and now we get everything passing. So these tests, going back to what is a test, these tests are coded ways of verifying that the functionality continues to work. Let's look at one more example. We're going to go into the calculator class. The calculator class has a single method called isPrime. It takes an integer number, so some integer, the argument is a number, and it returns either a true or false, true that it's prime or false that it isn't. Looking at it, it's a pretty basic brute force algorithm. We're simply going through all of the numbers, all of the divisors below number. If anything's evenly divisible, it's not prime. Otherwise, if it gets through all of them, it is prime. So pretty straightforward there. What we're going to do now is create some tests for our calculator class. So I'll start with one. We'll say calculator is prime, and let's just say number is 2. We're going to pass the number 2 in. So we'll say number equals 2. the expected here is going to be true. We expect 2 to be found as prime. That should be what happens. Now let's run our actual code. So we'll create a calculator object. And then we will get our actual value, true or false. The actual is going to be calculator.isPrime given number, and that'll come back as either true or false. If I hover over var, we'll see it's a system.boolean. Finally, we want to make sure that those are the same. So we'll make sure that expected and actual are the same. Expected being true, actual being whatever gets calculated. Let's go and run our test here. And we do get a passing test, which is not a big surprise. Let's go ahead and do one more. Well, let's do 2 more here. We'll do, the number is 3. 3 I would also expect to be true. Let's do one more as 4. And 4 I would expect to be false. 4 is not prime. So now I have 3 tests, one with 2, which should be true, one with 3, which should be true, it's prime, and one with 4, which is false, which is not prime. Let's run our tests, see how that works. And we get all passes. So we know our method is working as expected. One more thing I want to show on this one is, obviously with is prime, there are a lot of numbers that we could test. A whole bunch of numbers, millions and millions, billions even of numbers that we could test. But that's a lot. And if we wanted to test 2, 3, 4, 5, let's say all the numbers from 2 to 20, well, that's 19 different tests. 20 minus the one we're not going to use, it's 19. So 19 different tests that we'd have to do. That's a lot of tests. You can certainly do this and copy and paste and change your numbers, but there's another way that we can go. I'm going to change this up a little bit and show an alternative path where we say number is known primes. And now instead of int number, what I'm going to do is I'm going to create a list or an array that represents the primes that we know about. So let's say known primes up to 20. So we'll say int 32, these are known prime numbers, 2, 3, 5, 7, 11, 13, 17, 19. Those are our known primes. We do expect them to be true for each one of these. All of these should be prime numbers because we know about them. So what I'm going to do here, a little bit different than we did before, I want to go through each one of these numbers and make sure it's valid. So I'm going to do a loop. I'll do a simple for each loop. We'll say for each var number in known prime numbers. And then everything else is going to stay largely the same. We'll say calculator is prime given the number, and then we want that to be true. So let's run this test now. And now this passes. It succeeds, which is exactly what we'd expect. And now we've tested quite a few numbers, not just the 2, 3, and 5, or whatever the methods were that we were going to create. We can create a bunch of these. I can do the same thing with known non-prime numbers. And then again, get a bunch of, a big bang for our buck here. So we'll say number is known non-primes up to 20. So here we're going to do the inverse. So this will be 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20. So these are our known non-primes. It's basically the opposite of what we've got up here. So 4 is not here, 6 isn't here, 8, 9, 10, so on and so forth. Now our known non-primes should be false. And let's change this name so that it's non instead of known primes. Makes it a little bit easier to read what's going on. So the known non-prime numbers should all come back false. Let's run our tests one more time. And now we verify that everything is working. So this approach, we've got 2 different ways of testing here. What we can do is each case can be its own test method, or we can batch these values up and test several things at once. There's not a right and a wrong, like a lot of different things. It just depends on what makes sense at the time. Hopefully that helps demystify what is a test. It's a method that helps exercise the code that we want to verify, and then we can run that in an automated way to make sure that our code is still working.